All right, welcome to another basic science class. We started with electrical energy. I told you that electrical energy is gotten due to the flow of current. So today we want to continue from where we stopped, and I'm going to present to you some units and some symbols that will help you understand electricity. Now the unit of electricity or electric current is what we call ampere. Ampere is a unit for electricity or electric current, and this ampere is written as capital I. We are going to see it later, but know that ampere or the electric current is written as capital I. So from what we have on the board, we said that 1 ampere is the flow of 1 coulomb, that is 1 unit of charge of electricity in a time interval of 1 second. That's to say that 1 of this ampere is equivalent to 1 coulomb, that is a unit charge of electricity that flows at a particular second. So that is how it is counted. So note that the relationship of current, I, which I've told you earlier, that current is written as I, and the charge, Q, is given as follows. So this is a topic that involves a little calculation. So current I is written as this, while the charge is Q. Current is measured in ampere A, while the instrument used is ammeter. So you should know that current is being measured in ampere using an instrument known as ammeter. So the name ampere is derived from the instrument that is used in measuring the current. We have another terminology known as voltage. Sometimes you might have heard your parents say the voltage is high or the voltage is low. So this voltage is measured in volts with an instrument known as voltmeter. I've given you 2 instruments now. The first one is used in measuring current, known as ammeter, and the second one is used in measuring voltage, known as voltmeter. Ammeter is used in series connection. We are going to look at what series connection is all about. But note that ammeter is used in series connection, while voltmeter is used in parallel. That brings us to the 2 types of circuit. Before we get into the 2 types of circuit, I want to show you a circuit diagram here. This is battery, which we did in our last class. This is how battery is being represented. Don't forget that battery has a positive and a negative point. This A stands for what? Our ammeter. So this is our ammeter. This is the load, which when it's connected, this can serve as, if you can recall, I told you this sign stands for bulb. So this is our bulb, and this is our voltmeter that is used to measure the current that will flow into this bulb. While our ammeter is used in measuring, this is used in measuring the voltage, while the ammeter is used in measuring the current that will flow into the circuit. So I told you that the parallel connection and the series connection will lead us into the 2 types of circuit. So look at the type of circuit now. There are 2 types of circuit. We have the series and the parallel. Let's look at the series. The series circuit, this happens if the resistor, if 2 resistors or more are connected in such that the right end, please note this, the right end of the first resistor is connected to the left end of the second resistor. If such a thing happens, we say that that connection is done in series. The right end of one resistor, that is one wire, is connected to the left end of the second one. So just as we have on the board here, this is a series arrangement. You can see that this is one end, it's connected to another end, the edge of another end, just like that. So this arrangement is what we call series, because they lie on the same plane. So when a battery is connected to this arrangement, the current passes in a direct proportion. So because the current passes in a direct proportion, there is no break whatsoever. We say that the resistor is connected in series. I'll take it again, that when you see a series connection, it means that there is no break. Take for instance, you have, let me give you an illustration. You have a bulb, you have a wire, a long wire. You have your switch somewhere here, and that long wire, you connect bulb 1, bulb 2, bulb 3, and bulb 4. You discover that all these bulbs connected are linked to one wire and one switch. So the same current that flows into bulb A will flow into bulb B, C, and D. So this arrangement now is what we call series. All right, let's continue. This arrangement is what we call series. So let's look at parallel resistor. When resistors are placed side by side, such that their corresponding ends are connected together, it is known as parallel. When they are placed side by side in such a way that their connecting end is close to each other, it is called parallel. Just as we have here, we have series 1, series 2, series 3, series 4. They are placed side by side, and such a connection is known as parallel. Now let's look at the mathematical representation. This is where we have a little calculation. Now in representing the series resistor, we have R total to be R1 plus R2. Just as we have here. Please let's come back to this diagram. This is R1, R2, R3, R4. So the total or the net connection in this series will be R total. That will give you R1 plus R2 plus R3 as the case may be. So you add up this will give you the total resistor in this circuit. So that is what this formula is talking about. That the total resistor in series is R1 plus R2 as the case may be. While in parallel, it is a reciprocal. We talk of reciprocal, we are looking at inverse. So in parallel, like we have here, instead of saying R1 plus R2 plus R3, in this case, we'll say that R here is 1 over R1 plus 1 over R2 plus 1 over R3 as the case may be. So in parallel, it is the inverse. Now let's dwell on an example. Example 1. Find the current measured by the ammeter. Don't forget the ammeter is the instrument used in measuring current. And the voltage by the voltmeter. The voltmeter is used in measuring voltage. If the battery of 6 volts is connected as shown. So this is the connection. If a battery of 6 volts is connected to this, the voltmeter is 2 and 4. The question says, find the current. So how do we find the current? We start by calculating our net resistance. So you see that our net resistance from this equation or this formula is R1 plus R2. And R1 plus R2 is given, he said, note, resistor given, R1 is 2, R2 is 4. Now, taking cognizance to that, our resistance will be 2 plus 4. That is 2 plus 4, which will give us 6. Then, the formula for calculating current is volt all over resistance. So the volt was given, as 6 volts from our equation. Look at it here. It's given as 6 volts, and we have calculated our net resistance to be what? 6. So current will now be V all over R, which is equal to 6 all over 6. And from our calculation now, you discover that current is equal to 1 amp. So you can see that it's very simple. Putting up all parameters together, since they said calculate in series, you know that series is R1 plus R2, which is equal to 6. And when you now get the total, the net resistance, you now bring in the formula, which is current is equal to voltage all over resistance. You know your resistance to be 6, the volt was given, so all you need to do is to find current. So the current is equal to 1 amp. Now let's go to fuse. We all know what a fuse is. A fuse, when you look at some of the adapter, you see a structure, a piece of structure behind the adapter. So that is a fuse. So in definition, a fuse is a thin piece of wire that overheats and melts if too much current passes through it. So when you see a fuse and the current, the voltage in the house is so high, when the voltage is so high, the fuse will begin to melt. Why is it melting? Because too much current has entered it. So the major function of the fuse is to absorb the excess current that would have passed into our appliances. Now, apart from the fuse, there's what we call a circuit breaker. A circuit breaker is an automatic off switch that stops the flow of electricity in an overloaded circuit. There are times when we have thunder strikes. You see that the whole electricity in the house will go off, and you begin to wonder what happened. It is because the house is being controlled by a circuit breaker. So when this current comes in suddenly, the circuit breaker will switch off, and that will help to prevent that excess current from damaging our appliances. So that is the major function of the circuit breaker. It automatically switched off. All right, before I round up, I want to give you some electrical components and their symbols. In order for you to study this, when you get to your senior class, you study a subject known as physics. In physics, most of these things will be previewed again. So this is just a preliminary class so that you understand what you'll be seeing when you get to physics class. Now these are the symbols. We have electric component and symbols. Resistors in parallel is being represented by this symbol. So whenever you see this, you should know that everything there is being represented in series. We have our ammeter in circuit. It is represented as this. Voltmeter is V. Then we have our switch. This house switch is being represented in electric current. Then we have the capacitor as this. We have the inductor as this, the battery or dry cell, and we have the bulb. So I want you to look at these signs critically and equally learn to draw electric circuits on your own, indicating most of these symbols. And we are going to stop here, but before I leave, I want you to look at this homework. Try and see how you can solve it. A 12 volts electric cell is connected to a resistor of resistance 12 ohms, which is then connected in series. Don't forget, the connection is in series to a parallel arrangement of 2 ohms resistors of resistance 3 ohms and 6. The question is, calculate the current flowing in the circuits. Don't forget the formula of current as int. I is equal to V all over R. You've been given V, 2, 3, and 4. So know the total number of the V, and look for the total number of resistors, and you find your current. Try that. If you have any problem, you know how to reach out to me through our site. Have a nice day.